Hi, everyone. Thank you very much for joining us today on this webinar. I know there's a lot of things that are competing for your time, so I do appreciate you taking time out of your day to spend with us for this session. So hopefully we can give you something back in terms of understanding how data scientists and ML engineers practice production for machine learning in a low-ops environment. So, but to begin with, we'll start off with a little bit of housekeeping. If you want to move to the next slide, Nina. Yeah, so we want to keep this interactive as much as we can, but what we will do is if you can ask questions throughout the webinar via the chat function within the tool here. But then what you can also do is we'll answer the questions at the end, and that will allow us to get through the content, and then we can have a really good Q&A session at the end. So we've carved out time for that. We're also recording this, so we'll share this recording as well as the deck and the other resources after the webinar, so you can follow up. And if any other folks that couldn't attend today but still are interested in the content and watching this, they can follow up after the fact. And the content that we'll go through, as well as other content that we have available to our community, you can get some hands-on yourself. We have a free community edition with a license that doesn't expire, so you can actually install this on any of the major clouds, AWS, Azure, or GCP, and get some hands-on learning and go through that low-ops or DS first approach to production and getting your ML models into production on those projects. And we have a number of tutorials that go along with that, so you can get your hands on and start that learning journey. And we'd love to hear from you. We are a small startup. We are generating a community, and we're getting involved in the community more and more every day. So please let us know, what works, what did you like, what can we improve? So we want to make sure that this time is valuable for you as well. So before we get into it, I'll just quickly introduce myself. My name is Martin Bald. I'm the Senior Community Manager at Wallaroo.ai. And so it's my job to engage with professionals like yourselves in the data science, ML engineers, MLOps, etc. space to help engage, understand, hopefully trade some learnings and also use cases as well, and have that sort of two-way dialogue between our organization that we can feed into engineering, and also help you as well as you start along that MLOps production journey. I'll hand it over to my colleague, Nina Zamel, now to introduce herself and to take us through the rest of the session. Thank you.
Hi, I'm Nina Zamel. I am the VP of Data Science Practice here at Wallaroo, and we're here today to talk about low ops production machine learning. So probably the first thing we should do is define what we mean by a low ops data science organization. And the easiest definition is really to say it's one where the ratio of data scientists to ML engineers is high. That is, there are a lot more data scientists in the organization than there are ML engineers. Now, this is often the situation when organizations start their machine learning journey, because at least in the beginning of their journey, organizations are generally focused on exploring whether machine learning will bring value to their enterprise, how it can bring it, and what parts of the organization might best benefit. And they're more focused on that question than they are on the issues of trying to get any models they do deploy or they do deploy quickly into production. But as time goes on and their journey progresses and the machine learning development process matures, it's often the case that organizations will discover that data scientists may need lots of support trying to get the models that they develop into production in a timely fashion. And as that happens, organizations often find themselves having to staff up, have more ML engineers brought on to provide the support that the data scientists require. So let's drill down a little bit into why that might be. So I'm calling this the data scientist paradox. It's kind of a truism for anybody who's in data science that the part that most people think of as data science, that is the actual act of fitting the model, is really a very small fraction of the entire machine learning process, data science machine learning process, like say 10%. There's a lot that goes on before you fit the model. There's a lot that goes on after you fit the model. The part that goes on before you fit the model, I'm calling it on my slide here, the ideation and experimentation phase. This is the part where the data scientist is trying to frame the business problem that they're trying to solve. You know, how do I solve this best? How does machine learning help me solve this? They are exploring the data that is available to them throughout the organization to help them try to, you know, answer the question they're trying to answer, how to solve the problem they're trying to solve. They're trying to understand that data. They're exploring that data. They're seeing if that data is good quality. You know, what can we do to make it good quality? If it's not, where can we get more data? What features that are present in the data will be most useful for the models that the data scientist wants to fit? What other features can a data scientist synthesize, you know, feature engineering from the data that is available? And finally, what machine learning model or models might be best suited to solving the problem to the performance that the data scientist recovers. So that all happens before they actually, you know, find the model and fit it. And then after that, once you've got the model, you've got to integrate it into the operational infrastructure. This is a part of the slide here that's in blue that I'm calling production. You've got to integrate your model into the operational infrastructure. You've got to make sure that it performs well and behaves well in that operational infrastructure. You need to make sure that it is both time and resource efficient and isn't, you know, it works well within the entire production staff, and that it's robust and reliable. And there are issues and inefficiencies that can arise in this process because, generally speaking, data scientists tend only to be trained for kind of the part of the process here that I've got outlined in gold. That is the ideation, experimentation, and actually fitting the model. And they can often struggle with the transition of their model into production. So why do they struggle? Well, I would argue that as important as production considerations are, for many data scientists, these production considerations actually run counter to their training, their habits, possibly their own interests. I mean, there will be data scientists who are very good at this, but by and large, a lot of them are not trained for that kind of thing. To take a specific example, let's just talk about the production of code. Data scientists, because they're spending a lot of time in their ideation and experimentation phase, they tend to approach the production of code from kind of an exploratory mindset rather than a software development perspective. That is, a data scientist, when they're producing code, they're focusing initially on answering questions, on trying to gain understanding, not so much on trying to describe a specific repeatable process. And that is why data scientists often tend to prefer, you know, things like notebooks and other interactive programming environments, because those are the kind of environments that suit the ideation and experimentation phase well. Unfortunately, you know, they're going through these phases. They produce their code. They've got their model and some supporting code artifacts, you know, to help with the whole data science process, any pre-processing and post-processing. But because of the way that they approach coding, the code is often not well structured, and it can be very hard to deploy. So what often happens in many organizations is that it becomes the responsibility of the machine learning engineer to kind of take over the models and the code artifacts that the data scientists have produced and clean them up and productionize them to be compatible with production infrastructure. And as you can imagine, this is kind of this handing over of code and having to refactor code or containerize code or whatever can be a major time sink in the machine learning deployment process. And organizations often, again, try to address this time sink by staffing up the ML engineering side of the house to help try to speed up this process of getting the code, getting the models from the ideation and experimentation phase to the production phase. And even after the model is in production, data scientist's job isn't done. Data scientists may be called in to troubleshoot if people notice that issues arise with their models, the way they're behaving in production. They also need to be alert and monitoring the behavior of the models in production, looking for signs of concept drift or any other indication that the model is no longer behaving as it should be and possibly needs to be retrained. And again, this can be challenging for data scientists because they may not be accustomed or comfortable to working in a production environment. They also may not have direct access to the models and the model pipelines as they exist in production, especially if those models and code artifacts have been in some way containerized or refactored in order to put them into production. And they also, at best, may sometimes only have indirect access to the data that goes into the models and the data that comes out in the models through other systems of record, and may often have to troubleshoot the models that they have on pre-production versions of the models rather than on the production models themselves. And all of these issues can reduce a data scientist's effectiveness at trying to troubleshoot any issues that arise or trying to notice when it is time to retrain their models. So what we would like, what we're working towards, is a system that enables data scientists to be more self-sufficient, interacting with their models in a production environment, being less dependent on ML engineers, so that the ML engineers can focus on the other important aspects of their jobs. And that pretty much brings us to Wallaroo. And Martin, I will hand it over to you again.
Awesome. Thanks, Nina. Definitely, it's part of that conversation of, you know, there's a lot of energy and enthusiasm goes into that, you know, those early stages of ideation and experimentation, and then that development. And then if you flip to the next slide, I think this is how we think about it. And so, you know, happy to sort of generate some dialogue on this one. But projects that I've been involved in for AI and ML, you know, we took the focus of, you know, making sure we're all set up for the data prep. We had our data scientists, you know, we had the environment set up, you know, in ours was a retail example project that we were running. And so, you know, we had all those elements of, you know, defining the data, you know, organizing and labeling the data, and then, you know, going through that model training. But we didn't put any thought into the production side of things. And so we kind of got to that point where, hey, we proved that this works. And then it was like, oh, well, how do we make this production? How do we make this start paying back to the organization? And, you know, that conversation should be part and parcel of, you know, the whole journey from left to right. And so, you know, the way that we, you know, are sort of looking at it from, you know, not just the data scientist, but the ML engineer, is that, you know, the data scientists in a low ops environment, they may not have ML engineers that they can work with and collaborate. They need to be, as Nina said, self-sufficient through that whole production process, from, you know, getting those models uploaded, you know, serving those pipelines, you know, through to optimizing the models and then monitoring. But it also doesn't mean that any ML engineers that are, you know, watching this are thinking, wait a minute, what about my job? You know, what do I come in here? But essentially what we're trying to do is that, you know, as Nina says, you know, you know, have those best practices and that hygiene of cleaning up your code, so that we don't have an us and them approach, and those silos of, hey, I'm a DS and I'm a MLE, and those two worlds never meet, and we just throw things over the fence to each other. It's bringing them together. There's certain stages of that production process where they need to collaborate, they need to work together in order to ensure the success of that project and getting it into production and making it viable and sustainable for the business. And so if you flip to the next slide, Nina, and this is the approach that we've taken by building the Wallaroo platform in that production. We are that production platform. We help get you through at that point where you like, okay, we've got our model. We help you get it into production super fast. Help you scale and inference super fast through that compute engine, whether it's batch processing that you're doing or streaming of those models, and then also being conscious of, well, the job doesn't stop there when you're deployed. It's really important to make sure that you have the observability to make sure that, hey, is this model performing the way it should and the way we intended to? And we've seen situations, in the last 12 months with the economy, and Nina will go into this in the demo, where models that were built on, real estate prediction modeling, they may not be viable today. We have to have that engine where folks can, do that A/B testing, do that shadow deploy, hot swap those models in production without dehydrating and taking that whole infrastructure down and then causing delays and loss of ROI back to the business. And so, within the platform that we have in Wallaroo, we make sure that, that if you're a data scientist, if you're an MLE, if you're comfortable in a UI environment, we serve that to you. If you're comfortable in an SDK or Jupyter Hub, we serve that to you. And the importance of that is making sure that I function in an environment I know how to operate and I'm comfortable with, and I don't have to go for retraining. I don't have to sit and figure things out, because that takes time. That is a loss to the organization by causing those delays and those situations where people are not comfortable in the environment. And then also making sure that investments that you've made already, having those APIs so we can expose those other tools and resources that you've invested in, again, to help accelerate that route to production. So enough of me talking. What we're going to do is actually show this in action now. So I'll hand it back to Nina. Nina's going to walk through a demo of that journey into production and showing how the data scientist can make that happen for the organization. Over to you, Nina.
Thanks, Martin. A little bit of time here. Okay. So here I'm going to show an example of a data scientist in their usual, say, training environment, model training environment. In this case, it's a Databricks notebook. For this example scenario, I'm going to pretend that I'm a data scientist who's working for a real estate company. And my task is to build a model that will predict the house sale prices for the listings that are in my company's listings portfolio. I'm not going to go into great detail about the training part. This training notebook, you can consider it as sort of a consolidation of the ideation and experimentation phase. But that's not really the point of this webinar, so I'm not really going to go through it in great detail, except to say that in the process of my ideation and experimentation, I did come up with some feature engineering and pre-processing that I have to do to the data before it's fed to the model, which I have encapsulated in a Python module that I've called pre-process, and I'm importing a function from it here in this notebook. And that also, during my ideation and experimentation phase, I decided to build a model that predicts the logarithm of the price rather than the actual price, because I found that that improved the relative error performance of the models that I built. So I also have a simple post-processing module here that will simply, which I'm importing here, that simply will turn the log price that the model predicts back into a price now and round it to the nearest dollar. The rest of the first half of this notebook is just going to be the training of the model, splitting the training data, training a model, which in this case is going to be an XGBoost model, and making sure that it gets the performance that I need, the desired performance, behavior. So I have a trained model, and now I'm going to start going. Now we'd like to take this model that I've just trained and we want to deploy it. Now, Wallaroo's preferred model framework is Onyx. because that's a format that our high performance compute engine takes best advantage of. So the first thing I'm going to do with my model is that I'm going to convert it to ONNX, which is what these next blocks are. So I'm just importing some of the appropriate libraries, and I'm just going to convert that model to ONNX. Once I've got that model converted to ONNX, we now have a model artifact that we are ready to transition into production, which I can actually do right here in the same notebook. So the first thing I'm going to do is I'm going to connect to Wallaroo and myself some convenience functions. Here I'm going to connect to my Wallaroo instance. And there's one extra step here. Okay. I'm connected to the cluster now. And one of the concepts in Wallaroo, one of the concepts that is in Wallaroo is this notion of a workspace. This is a logical space where all the models and other artifacts for specific machine learning projects live in the production platform. With this workspace, everybody who's involved in the production side of a data science project, so all the data scientists, all the ML engineers, whoever else, can see and interact with the relevant modeling artifacts and coding artifacts and collaborate with each other. And so for this example, we're going to connect to a workspace that is called house pricing. And once I'm connected to that workspace, I can upload the model that you just saw me train and convert. And I'm also going to upload some pre-processing and post-processing modules. These happen to be, as you can see, the same pre-processing and post-processing modules that I imported earlier in the notebook. These are the same modules, in other words, that I used in training. I can use the same processing code that I used in training also in production. So I load those. And then once I've loaded all the model and all the modules, I can define a model pipeline, which consists, as you can see, of the pre-processing, the actual model, and the post-processing. And then what I'm going to do once I've defined that model is I'm going to deploy it, which means that it'll be ready to take inferences. Now, what this pipeline does once it's created, it automatically sets up a REST interface endpoint, a REST inference endpoint that will allow the model to be queried by other applications, and also manages all of the logging of any inferences that happen. And it's going to take a little while to do. And here we go. So now we have a pipeline, and it is deployed. And by deployed, that means that it's active and it is ready to take inferences. And I can actually show you what this looks like in the Wallaroo dashboard, which Martin mentioned. So we're going to go to the house pricing workspace. We can see that we've got a pipeline and 3 models. Here are the models that we just uploaded. And here is the pipeline that I just defined. And you can see the pipeline steps: pre-process, model, post-process. And you can also see that it's active. That means right now it's ready to accept inference requests. As I mentioned, the pipeline has defined for itself, it automatically has defined an endpoint through which requests can be made for inferences by external applications. But for convenience, we also have within our SDK and also within our API, a convenience function that will allow you to pass inferences into the pipeline from a notebook or a script, which is what I'm going to show you here, just to show you that it's alive. So what I'm going to do is I'm going to query our listings database, and I'm going to get 5 houses that have not yet been sold, and I want to make the predictions on what they'll probably sell for. And here I'm just going to wrap it into a format that the pipeline could accept, a JSON format. and send it to the pipeline to infer. And there are the predicted prices, which what I'm just going to do is I'm going to take those outputs and I'm going to link them to the listing ID in the house listing database, just to show you that here's a table of predicted prices for these particular listings in our listing database. And that's basically just how easy it is for a data scientist to deploy their trained models and the related processing artifacts to a production environment in really just a few lines of Python. What I'm going to do next is I'm actually going to undeploy this particular pipeline to free up its resources, which means it will not be able to accept inferences, but it's very, very easy to deploy it again when we need to send inferences back to it. And you can see that, hopefully you can see that. Here, the housing pipe is now inactive. So that was kind of transitioning the model into production. Now, as I mentioned in my earlier in the talk, data scientist's job isn't done even after a model's in production. So Wallaroo also provides a way for data scientists to monitor the behavior of these models once they are in production and inferring. And to show you that, I'm actually going to go to a different workspace and a different model. This one's actually not on. This is also a house price model. It's a kind of a different, it's a different model. And this model's actually been running for a while. And one of the functions, one of the features that Wallaroo provides is the ability to monitor the output of a model or its inputs, looking for drift in the distribution of the values that either go into the model or that are produced in the model. And in this case, we're going to look just at the output of this particular housing model. Specifically, Wallaroo has the ability to monitor the distribution of, in this case, an output value, a prediction, over regular windows of time, and compare it to a reference or database or baseline distribution that describes the expected behavior of the model. In the interest of time, I'm not actually going to show you how to define one of these monitoring processes, which we call assays, but I'm just going to show you the output of one instead for the month of January. Okay, so what are you looking at here? We are looking at an assay, a monitoring process on the output of a house price prediction model. In this particular model, what we've set up is a process that every day looks at the previous 24 hours of predictions, looks at the distribution of them, and compares them to a baseline distribution that describes how we expect the model to behave. And the idea is, if the distribution of prices that comes out of the model changes, then the behavior of the model is changing in some way that we should pay attention to. So every day we take the day's distribution of prices, compare it to the baseline, take the difference between those two distributions by some metric. In this case, it's the population stability index, but there's multiple metrics. And if that difference exceeds a threshold, which in this case is 0.1, that means that we will consider that evidence that the behavior of a model has changed substantially from its typical behavior. And then it might be some kind of intervention is possibly needed, including possibly retraining. So just to kind of dig down a little bit on what that looks like. Here on January 3, there was we see that there wasn't very much difference between the window and the baseline. So if we click through on it, here's kind of the direct comparison. The blue histogram represents the baseline distribution of price predictions from this model. This is how we expect the model to behave. It's how the model behaved in during the training phase. Okay. And the yellow histogram represents the previous 24-hour distribution of predictions. And as you can see, they're overlaid substantially. So basically, you can say this is evidence that the model is pretty much behaving as we would expect it to behave, and the world is behaving as we expect it to behave. But if we go back here, over here to January 21st, here you see again, the blue is the baseline distribution. The yellow is the previous day's distribution of prices. And you can see that the predictions that the model was making are beginning to trend upwards. The model is overall making higher predictions than we would expect it to make. This possibly could indicate that there's some change in the sort of houses that we're seeing in our listings. So the kinds of houses that the model considers more expensive, say larger ones or ones in more desirable neighborhoods, are coming on the market at a higher than we expect rate, and therefore the model is behaving differently. This could be an indication that there's been some substantial concept drift in the environment and that it may be time to retrain the model. And of course, I mean, we're doing this indirectly with outputs, but we could, in fact, also set up assays to observe key inputs to the model directly, which would be a way of more directly monitoring for concept drift. So that's a very quick overview of how Wallaroo helps data scientists deploy their models and observe them in production in an environment that is somewhat more familiar and more comfortable for a data scientist than perhaps a standard machine learning engineering environment is. And now I'm going to turn it over to Martin if you were interested in what you saw and would like to explore more, I'll turn it over to Martin to explain how you might be able to do that.
Thanks, Nina. Yeah, if you want to flip to the next slide. So what we saw from Nina there was the capability of data scientists taking their models, converting them into format. So you can bring your own model into the platform, and then get them into production, do that observability and optimization as well. And so that's important. I think as Nina sort of showed there from the observability piece, I think data drift is definitely something that is important for ML projects to be aware of. I mean, drifting might be fun in a sports car, but in the ML world, it's something that you need to be proactive and aware of occurring. And so with the community edition, we have this free opportunity where you can get some hands-on learning. You can start that production learning journey for yourself and install it in any of the major clouds, whether it be Azure, AWS, or GCP, and you get all the tools and features and capabilities that Nina showed you there, through testing, validation, hot swapping, A/B tests, etc., and that fast compute engine in the background as well, and it's free. Which as a Scottish man, free is my favorite word. I'm sure it's especially in today's prices. Free is a good thing to have. And the other important thing is it doesn't expire. And in some cases you're limited to it. You've got 30 days or 60 days. And we don't always have that bandwidth to devote time to trying out these technologies and getting that learning into our sort of bailiwick. And so this is unlimited. You can download it today. You can not touch it for another couple of weeks, and then start running through those tutorials as well. And so, Nina, if you flip to the next slide, just quickly, with that community edition, that where we are is essentially what we sort of covered throughout the session, is that we are that model operations center. When you go through the ideation, when you go through that model development, and then you get to that point where, as I discussed, we're like, well, how do we get this into production? And that's where the Wallaroo platform comes in. It allows you to quickly get those into deployment. And if you saw from Nina's demo, it took her a matter of seconds to deploy those pipelines within that workspace, And if anyone here has been through an actual production process, you can appreciate that that can take hours or days, with a multitude of different tools and configurations to take care of. So, under a minute is a super fast way to get you from undeployed into deployed and production as well, and making sure that they are viable to the organization. And then also, as I mentioned, we all make investments in other technologies. How can we expose those and get them plugged in to that, so we can leverage all those investments that we've made? And then if you want to flip to the next slide. So what we do as part of the community within Wallaroo, as well as every 2 weeks, we have these little tech talks. They're like 30-minute quick deep dives into a specific topic. And what we'll be doing next Wednesday, if you'd like to join us, is our colleague Will Berger, who is a CSS engineer. He is the front line with our customers, helping in their deployment success. And we go through this, the Waller Azure Databricks integration, but we'll also use it from the perspective of using computer vision models, so you can see a different style of use case for taking those models, get them into that model format, and then getting them out to production. So yeah, please definitely encourage you to join us next week, and we'll keep that interactive as well. Also. And then if you flip to the next slide, I've probably talked a lot. I've mentioned a lot of things about, community edition, how to reach us, other, blog posts that we have on our website, and we have a rich, wealth of documentation that we're adding to regularly every week. And we also have a Wallaroo YouTube channel, which we're posting videos and content to on a weekly basis. So there's a lot of different aspects there available to you to get hands-on, get learning, and find out, ask us questions and get engaged, and hopefully, we can generate some of those discussions and help you in that production journey. I'll stop here. I think we're at the point where it's opportunity for our audience, yourselves, to ask some questions of us. Also let us know if you have any specific use cases you want to share. And so I'll hand it over to our colleagues and just see if there's any questions in the queue.
Hey Nina, hey Martin. Question came in. Can any data scientist deploy anywhere, or how do you manage access and security?
Yes, the platform is designed to integrate within the organization's existing infrastructure. So we do have a variety of ways to address the security, whatever security protocols are used by that organization. We are showing SSO and Keycloak. There are other ways to do it, and we have a variety of ways that you can interact with our SDK. The platform actually comes with an integrated Jupyter Hub, so you can actually, data scientists can actually develop right there. I'm sure actually probably a lot of them already have existing environments in which they like to develop. So the SDK can also be called from a variety of existing environments. So I showed it in Databricks, and we have some others as well.
I think in terms of the security aspect, how do you manage access control, Nina or Martin?
That I'm afraid that is not a question that I'm completely qualified to answer. Sorry.
So access control with Wallaroo, like I mentioned, installs on your cloud. So wherever you have your cloud subscription, if it's Azure, AWS, or GCP, and we leverage the services and the robustness that those cloud technologies have. And then you also saw from Nina's demo that when she did create the workspace and go through the demo, that actually invoked an authentication with her to say, are you who you say you are? And so that is also built into the product. but also leveraging the capabilities that companies have, whether it be like AD or ADFS or other security layers within their investments.
And I think the only thing I would add is that we have this workspaces paradigm where you can give different access levels or different levels of access. So you can give people view-only access to only a specific model or a set of specific models, and then there's access that lets you deploy or edit models. So it's not a free-for-all, and there's full logs for in terms of compliance and audit within the platform. Next question is, and by the way, we have a blog post that's all about admin and access controls and compliance that we can share afterwards. Next question, is Wallaroo a SaaS, or how does it run?
It is not software as a service. It is something that you install into your cluster or on-prem, and it is running within your ecosystem. So it is not a service.
Which, by the way, is a pretty good advantage because we're not taking custody of your data at all. So that just makes it easier. And then last question, it's around, I'm having a hard time parsing this. Is auto retraining possible?
We have not gotten to that feature. We currently focus on what happens after training, so the transition from training to production deployment. The data drift and concept drift detection that I just showed you would be a precursor to that. So basically, once you see that your model inputs or outputs, whatever you're monitoring, start to drift, and that it may possibly be time for intervention, that is in fact a signal that it may be time to retrain. So right now it's not auto retraining, but we're certainly putting the pieces in place for someday having that.
Perfect, that's great. Those are all the questions I have on my end. Thanks, guys.
Awesome. Thanks very much, everyone. As I mentioned at the beginning, I know there's a lot of things competing for your time, so we do appreciate that you chose to spend it here today. I hope it was useful and valuable for you. We will, as I mentioned, we have recorded this, and we'll send out the links to the recording and the decks. And hopefully you'll join us next Wednesday for the community deep dive into getting those models into production, and then we'll continue this dialogue. We also want to hear how we can improve. Some things we do right, some things we don't do right. So please let us know. We want to make sure that we continuously improve not just the product, but sessions like this so that they're valuable for you. So once again, on behalf of everyone, thank you very much for your time, and enjoy the rest of your day or evening. Bye-bye.